Hello everyone, this is Mr. Crozier and I am here for our first day of remote learning to help you with the material this week. We're going to start with lesson 9.1 in the book and then we will continue with chapter 9. Um, After today's lesson, most of the problems will be out of the textbook. So here we go. Lesson 9.1, Simplifying Radicals. We have worked with square roots so far this year, and we know that some common square roots, and we're going to call them starting now perfect square roots. The square root of 1 is 1 because 1 times 1 makes 1. Square root of 4 is 2, and square root of 9 is 3, and square root of 16 is 4, and square root of 5 is, 25 is 5, 36 is 6, square root of 49 is 7, square root of 64 is 8, and you can keep going further. But now we're going to run into a situation where we have numbers that are not perfect square roots, such as square root of 20. There are not two numbers that multiply together to get 20. You could say 20 is 4 times 5, but that's not the same number. So we need two identical numbers that multiply to give 20. Well, the square root of 16 is 4 and the square root of 25 is 5. So if you're looking for the square root of 24, it's somewhere in there. If you type it in a calculator, you'll get a decimal, which is about 4.47. That is just rounded. This is an irrational number which never ends, but we're going to say it's about 4.47. And again, in the case of the square root of 59, the square root of 50, the square root of 50 cannot be written as two identical numbers, so we're just going to try and estimate it, and the square root of 49 is 7. Square root of 50 is just a little bit bigger than 7, comes out to be 7.07. But again, this is a never-ending irrational number. It does not repeat. All right, we're going to spend a lot of time working with square roots, and we don't want to have to deal with these decimals. So what we're going to do is learn how to simplify square roots. And that is something you did in middle school with fractions. I'll just give you an easy example right here. In middle school, your teacher probably wrote 2/8 on the board, and your job was to simplify that into an equivalent fraction of 1/4. We're going to use that same concept of taking a complex version of something and make it into a simpler version of the same thing. But we're going to be working with radicals today, and we're going to keep one rule in mind over here. The square root of a times b is the square root of a times the square root of b. They are broken apart. So if you remember this rule, it will help you out in this lesson. So here we go. Here's a first typical problem. What is this, or please simplify the square root of 20. Well, if I use this rule, I know that the square root of 20 is really 4 times 5, right? 4 times 5 makes 20. And I could break that apart even further and get the square root of 4 by itself and the square root of 5 by itself. And why in the world did I do that? And I'll tell you why I did that. It's because I know what the square root of 4 is. The square root of 4 is 2. But we don't know the square root of 5. It cannot be simplified down any further. So the square root of 20 is the same thing as the square root of 2 root 5. That's our goal in these lessons. Just like in middle school, 2/8 is the same as 1/4. In high school, the square root of 20 is the same as 2 roots of 5. All right, on the next problem, we have the square root of a fraction. Well, we simply take the square root of the numerator over the square root of the denominator. Well, the denominator is easy. The square root of 9, that's a perfect square. But the square root of 50, we don't know what that is. So that's the square root of, but I do know it's the square root of 25 times the square root of 2. And why did I divide it up this way? Because I could have divided it as the square root of 50 is 5 times 10. But if I divide it this way, square root of 25 is a perfect square. 5 square roots of 2 over 3. So the thing to keep in mind here is you're always looking for perfect squares. You're dividing them up, kind of just like the factoring that we just finished. All right, I have 4 more examples here that you can copy down. Simplify this expression. Well, 2 is 2, but the square root of 18 is not a perfect square, but it is the square root of 9 times the square root of 2. 9 times 2 is 18. Perfect. All right, let's see here. 2 is 2, and with the square root of 9 is 3, and the square root of 2 is an irrational number that's not going to simplify. And if I do the math that I know how to do, 2 times 3 is 6. 6 square roots of 2. All right, square root of 10 times square root of 2. Well, square root of 10 is just 2 and 5, and I don't know those roots. Square root of 2 is, well, that can't be simplified any, but I can put them together into the square root of 20. And now wait a minute, I know what the square root of 20 is. That's the square root of 4 times the square root of 5. So that's 2 root 5. So the square root of 10 times the square root of 2 is 2 root 5. Again, there are decimal approximations. However, we are not using decimals. All right, now we have the square root of 9x squared. We have to work with some fractions. Well, we do this, or sorry, we have to work with some exponents. So we're going to split this up. Well, that's easy enough. All right, and let's see here. I'm going to draw this a different way just to make a point here. Let me change the color. Let's see. The square root of 9, well, I'm going to write this as 9 is 3 times 3, so the square root of 9 is 3. And, well, what is x to the 6th? Well, that is x to the 3rd times x to the 3rd. Remember, we add these exponents, so the square root is just x to the 3rd. So it's a little tricky there, but you just have to be careful about the way you work with numbers and the way you work with variables. There is a difference, and we can cut the exponent in half and get x to the 3, but we don't cut the 9 in half. 9 is 3 times 3. All right, last problem. Square root of 8 x to the 7th. Well, let me divide up the number. That would be square root of 4 times square root of 2. And let me divide up the exponent this way, and you'll see what I'm doing here. I'm going to go ahead and say x to the 7th is x to the 6th times x to the 1st, because if I add 6 and 1, I get 7. All right, square root of 4 is 2. Root of 2 can't be simplified. Square root of 6, well, I just got done doing this, or x to the 6th is x to the 3rd. And the square root of x to the 1, well, there's nothing that can be done with that. And to finalize it, let's just put it in a nice, neat order. We'll say I have 2x to the 3rd. Those are the numbers that came out of the radical sign, and still under the radical sign I have a 2 and an x. All right, I hope this helps with your lesson today. Please email if you have any questions. I will be happy to help.